Hey everyone, welcome back to my channel. I'm Neil and today we're diving into coordinate geometry. Before we jump in, make sure to subscribe so you don't miss any of my upcoming videos on this topic. Without further ado, let's get started. First of all, I'm going to talk about number plane, which is known as two-dimensional plane. So in any number plane, we have two axes. The first one is x-axis, which is a horizontal line, and y-axis, which is the vertical line, and they are perpendicular to each other. And then we can show a position of a point with ordered pair. For example, point A, which is x and y. X is coordinate, x coordinate, and this is y coordinate. And using x and y, we can show the position of any point. In fact, x is horizontal step from O O is here, which is origin, and y is vertical steps from O. For example, we have point A, which is positive 3 and negative 2. In fact, the x coordinate or horizontal steps is 3 units, so we can go 1, 2, and 3 units to the right, and then go 2 units down because we have negative 2 as y coordinate, and 1 and 2, which is negative 2, and connect these 2 points. So point A is located here with x and y coordinates positive 3 and negative 2. And then the axis divide the number plane into 4 quadrants. So we can call this Q1, quadrant 1, Q2, Q3, and this is the last one, which is Q4. If a point like M with coordinates x and y is located in Q1, so the x is a positive value and the y is positive as well. For example, we have a point here. The x coordinate is positive 2 and the y coordinate is positive 1. So both x and y accept positive values. And how about Q2? In Q2, for example, here we have a point and x here is a negative value and y is a positive value. So in Q2, x is negative and y is positive. And for Q3, for example, we have a point here. The x coordinate is a negative number and the y coordinate is negative number as well. So x and y are both negative. Last but not least, Q4. For example, we have a point here. X is a positive number, but y is a negative number. So x is positive and y is negative. So far, so good. According to these facts, I'm going to solve an example related to that. For example, we have point A with x coordinate n plus 5 and y coordinate negative n minus 4. And we know that this point lies in Q2. And we are going to determine the range for m and n. So range for m and n. Okay, we know that in quadrant 2, x is a negative number. So because x is a negative 1, so m plus 5 should be less than 0. So this is a really easy inequality. I'm just gonna subtract 5 from both sides of the equation. So subtract 5 here and then here. These two cancel out. So m is less than negative 5. So this is the range for m. And how about negative n minus 4? So in Q2, y is a positive value. So negative n minus 4 should be larger than 0. So y is positive. So negative n minus 4 is bigger than 0. So negative n, we can add 4 units and these two numbers cancel out. So negative n is bigger than positive 4. So I'm going to get rid of this negative coefficient by dividing by negative 1. So negative n over negative 1, 4 over negative 1. And as you may know, when you divide both sides of any inequality by a negative number, you should change the sign. So the sign would be here. And the final answer is n less than negative 4. And this is the range of n. Let's find a point using m less than negative 5 and n less than negative 4 to check if it works or not. Okay, for example, m less than negative 5, let's use negative 6, and n less than negative 4, like negative 5, and substitute the values of m and n into point A. So A is m, which is negative 6 plus 5, and n is negative 5 minus negative 5 minus 4, and simplify this. So A is negative 6 plus 5 is negative 1, and negative minus 5 is positive 5. Positive 5 minus 4 is positive 1. And if we found this point, in xy plane, A is negative 1 here and positive 1 here. So point A is here, and you can see that A is located in Q2, which is mentioned here. So our answer is completely correct. Perfect. As another example, we have a point A with coordinates negative 4x plus 8 and y squared minus 9. And this point lies on origin. So lies on origin, or O. And we are going to find the values of x and y. Perfect. We know that the origin is the point here, origin, which is the intersection point of x and y axis. And origin has coordinates 0 and 0. Let me write this. So the x coordinate is 0 and the y coordinate is 0. So the x coordinate should be 0. And this is the x coordinate. And this is the y coordinate. Let me write this here. Negative 4x plus 8 should be 0. So this is a really easy equation, and negative 4x is negative 8. Divide both sides by negative 4. So x equals positive 2. And how about y coordinate? Y squared minus 9 equals 0. So y squared is 9. And because this is a quadratic equation, y can accept two values, positive and negative 3. In fact, if x is 2 and y is positive 3 or even negative 3, the point A will lie on origin. Let's check our answer. X is 2, so negative 4x, and y squared minus 9, positive or negative 3 squared minus 9. Okay, negative 2, negative 4 plus 8, sorry. Negative 4 times 8 is, negative 4 times 2 is negative 8, and negative 8 plus 8 is 0. Positive or negative 3 raised to the power 2 is positive 9, so 9 minus 9 is 0. So A is 0 and is located on origin. So our answer is completely correct. Okay, let's go to another topic, distance between 2 points. Okay, consider point A as 2 and 4 and point B 5 and 2, and we are going to find the distance between these 2 points. Okay, I'm gonna draw a two-dimensional plane. Okay, A is 2, positive 2, 2 steps to the right, and positive 4, 4 steps up. So point A is here, and then point B is 5 and 2. 2, 3, 4, 5, 5 here, and 2. Okay, and this is point B, and we can join the points, point A and B, by a straight line segment. Okay, and we can call this D as the abbreviation of distance. And so the length of A and AB is D units. Okay, so I'm gonna draw a right angled triangle where AB is the hypotenuse of that. So this is a right angled triangle because this line, this is a vertical line and this is the horizontal line, and they are absolutely perpendicular. Okay, and then you can see that for finding the value of D, you just need to find the length of this side and the length of this side and use Pythagoras' theorem. So you can see that this is 2 units. So 2 units. And this is 1, 2, 3 units. Okay, so according to, so let me write this, the hypotenuse is A, B here. So according to Pythagoras theorem, D squared, the square root of hypotenuse, equals 2 squared plus 3 squared. So D squared is 4 plus 9, which is 13. And in order to find d, we just need to find the square root of 13. In fact, d, or the length of AB, is radical 13 units. Okay, and how we can find the distance between 2 points without plotting points and drawing a straight line segment? Okay, so I'm gonna use a formula, and this formula is this. The distance is the difference of x's of 2 points squared plus the difference of y's of 2 points squared, and find the radical or a square root of sum of them. Why? Because as you can see, these 3 units is x changes. The x of point A is 2, and the x of point B is 5. And in fact, for finding the length of this line, we just need to subtract 2 from 5 and find the x changes or difference of x's as x steps. So let me write this, that this line is x changes or x steps. And how about this one? Let me draw this here. And this is y changes of 2 points, because the y of A is 4 and the y of B is 2. So 2 units is difference of 4 and 2. So for y changes or y steps. And why we found the square of them? Because we are going to use Pythagoras theorem. So you should find the square of them. So this is a formula for finding the distance of 2 points. Okay, so I'm gonna solve another example using this formula. For example, point A is 2 and 1, B is -2 and 0, and C is 1 and -3. And we are going to determine if the triangle ABC is equilateral, isosceles, or scalene. So for finding out the type of triangle ABC, we need to find the lengths of all 3 sides of this triangle. Let's start with lengths of AB. So we are talking about these 2 points. Okay, so according to formula, we should find the square root of x-axis. So 2 minus -2, or -2 minus 2. It doesn't matter to check the order, because if you subtract -2 from 2, the answer is +4, and after finding the square of 4, the answer is 16. But if you subtract 2 from -2, the difference is -4, but -4 squared is +16. So it's okay. You don't need to think about that. Okay. So 2 or -2 minus 2 squared plus 0 minus 1 squared. So we have -2 minus 2, -4 squared is 16. 0 minus 1 is -1, -1 squared is 1. So AB is the square root of 17. Okay, and how about AC? Difference of x's. Okay, A and C. 2 minus 1 squared plus 1 minus negative 3. Okay, 2 minus 1 is 1, 1 squared 1, 1 plus 3 is 4, 4 squared is 16. So AC is a square root of 17. And how about the third side, which is BC? Okay, BC. Negative 2 minus 1 squared plus 0 minus negative 3, which is positive 3. Negative 3 squared is 9. 3 squared is 9. So BC is a square root of 18. So you can see that we have three values of three sides: radical 17, radical 17, and radical 18. So we found out the triangle ABC is an isosceles triangle because it has two equal sides in length. Okay, it was a great example. And jump into the next one. Point P is negative 1 and A plus 4. And point Q is minus A plus 2 and 3. P and Q are two radical 2 units apart. So let me write this. Are two radical 2 units apart, and we are going to find the value of A. So we know that PQ, or the length of them, is 2 radical 2, or you can use radical 8. Okay, how can we find the value of A? So I'm going to use the formula PQ equals difference of x's squared plus the square of difference of y's. So this is x coordinate of P and this is x coordinate of Q. So negative 1 minus negative A plus 2 squared plus A plus 4 is y value, y coordinate, and for Q is 3. So A plus 4 minus 3 squared. And don't forget to write the square root of that. Okay, so and PQ is radical 8. So we have this equation and we should simplify and solve for A. We know that we have a negative sign here, and according to distributive law, you should distribute this negative sign and multiply by all terms inside the parentheses. So negative 1, negative times negative A is positive A, and negative times positive 2 is negative 2 squared. And you can simplify this more. Negative 1 and negative 2 is negative 3. So A minus 3 squared and A plus 1 squared. Okay, we have a minus 3 squared, and I'm gonna use this identity a minus b squared. This is a perfect square identity. A squared minus 2ab plus b squared. So a squared, 2y of 3 is negative 6a plus 9. And a squared is here 2y of a plus 1. Okay. A squared plus a squared, I'm gonna collect like terms, 2a squared. Negative 6a, positive 2a is negative 4a, and 9 and 1 is 10 equals 8. In fact, I cancel out these two square roots. Okay, so put 8, take 8 to the right side of the equation. So 2a squared minus 4a plus 2. This is a quadratic equation. Okay. There are different strategies to solve a quadratic equation. I'm going to use factorization. So first of all, factor out 2. A squared minus 2a plus 1 equals 0. So a squared minus 2a plus 1 is 0. And you can factor out it as a minus 1 squared equals 0. So a minus 1 is 0, and the answer of a is 1. So we can check if it works. So a is 1, substitute 1 here. 1. So we have negative 1 and 5. Negative 1 and 5. And substitute 1 here. Negative 1 plus 2 is 1 and 3. And if you found the distance, negative 1 minus 1 squared plus 5 minus 3 squared is gonna be negative 2 squared is 4. Positive 2 squared is 4, and 4 plus 4 is radical 8, or 2 radical 2, which is completely correct here. Okay, if you found this video helpful, hit the like button and stay tuned for part 2, where we'll go deeper into coordinate geometry. See you soon. Bye-bye.